Let's swing into the action. So, the first question that pops up in your mind is, what can Kubernetes do for you, do for me, do for us? So, with modern web services, users expect application to be available 24 by 7, and developers expect to deploy new versions of those applications several times a day. I hope you might also be expecting these kind of things. You would also want to see the versions upgraded every several times a day. So to do all those things, containerization helps package a software to serve these goals. So enabling applications to be released and updated without downtime. So Kubernetes helps you make sure those containerized applications run where and when you want, and helps them find the resources and tools they need to work. So Kubernetes is a production ready open source platform designed with Google's accumulated experience in container orchestration combined with best of breed ideas from this community. So let's look into the production level Kubernetes flow. Production ready Kubernetes flow. So it begins with creating a Kubernetes cluster. So Kubernetes coordinates a highly available cluster of computers or instances or virtual machines that are connected to work as a single unit. The abstractions in Kubernetes allow you to deploy containerized applications to a cluster without tying them specifically to individual machines. To make use of this new model of deployment, applications need to be packaged in a way that decouples them from individual hosts. They need to be containerized. So containerized applications are more flexible and available than in past deployment models where the applications were installed directly onto specific machines as package deeply integrated into the host. Kubernetes automate Kubernetes automates the distribution and scheduling of application containers across a cluster in a more efficient and effective way. So Kubernetes is an open source platform and is a production ready. So then the second step in the production ready flow is to deploy an app into our cluster. So once you have a running Kubernetes cluster, you can deploy your containerized application on top of it inside the cluster. So to do so, you create a Kubernetes deployment configuration or Kubernetes deployment object or a Kubernetes deployment resource, whatever the way you call it, but the purpose is to deploy it. So the deployment instructs Kubernetes how to create and update instances of your application. Once you have created a deployment, the Kubernetes control plan schedules the application instances included in the deployment to run on individual nodes in the cluster. Then the third step is explore your app. So when you created a deployment in step 2, Kubernetes might have created a pod to host your application instance. A pod is a Kubernetes abstraction that represents a group of one or more application containers such as a Docker and some shared resources of those containers. Those resources include shared storage as volumes, networking as a unique cluster IP address, information about how to run each container, such as the container image version or specific ports to use. Then the fourth step is expose your app publicly. So Kubernetes pods are mortal. So pods have a life cycle. When a worker node dies, the pods running on the node are also lost. So that's the reason a replica set. A replica set might then dynamically drive the cluster back to the desired state via the creation of new pods to keep your application running. As an as another example, consider an image processing backend with 3 replicas. How many? 3 replicas. Those replicas are exchangeable. The front end system should not care about backend replica or even if a pod is lost and recreated. So that said, each pod in a Kubernetes cluster has a unique IP address. Even pods on the same node will have a unique IP address. So there needs to be a way of automatically reconciling changes among pods so that your applications continue to function. A service in Kubernetes is an abstraction service, a service object. A service object in Kubernetes is an abstraction which defines a logical set of pods and basically applies a logical set of pods and a policy by which to access them. So services enables a loose coupling between dependent pods. A service is service is defined using YAML, YAML script or JSON, that is JSON, like all Kubernetes objects. The set of pods targeted by a service is usually determined by label selector. So then scaling an application. So in the previous step that we have discussed, that's expose your app publicly. That time we have discussed about the replica and then we also discussed about the service. So we in previous steps we have created a deployment and then exposed it publicly via a service. If you want to expose the app that you have created into the Kubernetes cluster in the step 2, if you want to expose it to the external world, the option for you in Kubernetes is using the service object. So the deployment created only one pod for running our application. When traffic increases, we'll need to scale the application to keep up with user demand. So that's why we will go with the scale up of our app. Then the final one, this is what we do for the scaling up. And final one, the sixth step is to update our app. So users expect applications to be available all the time and developers are expected to deploy new versions of them several times a day. In Kubernetes, this is done with rolling updates. Rolling updates allow deployments update to take place with zero downtime by incrementally updating pods instances with new ones. The new pods will be scheduled on nodes with available resources. In previous module, we scaled our application to run multiple instances. That's in step 5. So this is a requirement for performing updates without affecting application availability. By default, the maximum number of pods that can be unavailable during the update and the maximum number of new pods that can be created is 1. Both options can be configured to either number or percentages. So in Kubernetes, updates are versioned and any deployment update can be reverted to a previous stable version using rollout.